Imagine opening the book of Earth's history and discovering that someone has torn out an entire chapter, not a few pages, not a single epoch, but 1 billion years of the story simply missing, ripped away with a precision that defies everything we know about geology. When scientists first uncovered this void, scattered across continents and appearing exactly where it should not, they gave it an ordinary name: the Great Unconformity, a simple phrase for something that should not exist. If you travel to the Grand Canyon and stand at the edge of those ancient cliffs, you can actually see it with your own eyes. A line that separates two worlds. Below it, rock nearly 2 billion years old. Above it, rock that formed hundreds of millions of years later. Everything that should exist between them is gone, eroded, erased, removed so cleanly that the missing time leaves no fossils, no sediments, no trace of the life that may have existed there. The same line appears in Scotland, in Australia, in the Canadian Shield. Across 4 continents, the Earth presents the same impossible silence in the record. It is as if the planet suffered an event so powerful, so absolute, that it reached deep into the geological archive and swept away an entire era. This void is not a local anomaly caused by regional erosion or seasonal weather. It is global. It is synchronized. And it appears exactly before the moment when complex life emerges in sudden and overwhelming abundance. For decades, this gap was treated as a geological inconvenience, a strange but ultimately ignorable detail in Earth's long story. But the more closely researchers examined it, the more disturbing it became. Rocks do not simply vanish from every continent without leaving scars. Sediment does not disappear from the fossil record without leaving evidence of the processes that removed it. But here, the scars are too sharp, the erasure too complete. It looks less like a natural progression of geological forces and more like a reset. 1 billion years gone, 1 billion years with no clear explanation. Before we go any deeper into this mystery, feel free to tell me in the comments where you are listening from and what time it is for you right now. And as always, the visuals you see here are simply meant to accompany the story, not define it. Thank you for being here and for supporting this journey. The missing interval spans a time when Earth was transitioning from a planet dominated by simple microbes into a world preparing for an explosion of biological complexity. If the story of life is a long arc rising from elemental chemistry to consciousness, then this gap sits at its hinge point. Right before the curtain rises on the Cambrian world of eyes, shells, nervous systems, predators, and ecosystems. Right before the sudden emergence of every major animal body plan. Right at the dawn of what we recognize as life capable of perceiving, reacting, and evolving with speed. The timing is too strange to ignore. Why would nature erase the exact period when the building blocks of complexity should have been forming? Why would the Earth remove its own origin story? Some scientists point to massive glaciations. The snowball Earth hypothesis suggests that ice sheets once covered the entire planet, grinding continents down like sandpaper. Others argue for tectonic shifts, supervolcanoes, or early mountain building, but even those explanations fall short. Glaciers can erase rock, but not at this scale. Volcanism can melt landscapes, but not with global uniformity. Tectonics can shift continents, but not carve away 1 billion years so cleanly across such vast distances. The Great Unconformity does not behave like a natural accident. It behaves like an event, a singular moment in Earth's history when something happened that our current frameworks cannot fully capture. To understand how unusual this gap is, imagine reading human history and discovering that the entire stretch between the Stone Age and the Renaissance has vanished from the record. No ruins, no bones, no tools, no signs of culture or development. And then suddenly, the Middle Ages begin. That is the scale of the mystery we face. 1,000 million years of Earth's early story missing, right before the most dramatic leap in biological innovation the planet has ever seen. And the deeper we look, the stranger it becomes. Some of the earliest geologists who examined these discontinuities did not fully grasp their significance. They lacked the global datasets, the satellite imagery, the radiometric dating we use today. But even in the 1800s, something about the missing layers unsettled them. The boundaries looked too abrupt, the ages too mismatched, as if the Earth were not simply evolving, but reorganizing itself. Today, with advanced dating techniques, we can measure the ages of these rocks with breathtaking precision. And the numbers raise even more questions. They reveal that the missing interval is not the same everywhere. In some places, 500 million years are gone. In others, 1.5 billion. This suggests that whatever caused the erasure did not operate like a single natural process. It acted differently across regions, yet left behind an eerily consistent global signature. It is almost as if the planet was wiped clean in stages, or as though multiple events were layered on top of each other, culminating in a final, world-resetting transformation. But the greatest mystery is not the missing rock. It is what comes immediately after. Right above the line where 1 billion years should be, the fossil record shifts dramatically. Life becomes complex, multicellular, structured, coordinated. It develops eyes, muscles, shells, predators, prey, ecology, behavior. The world changes faster than at almost any other time in history, and yet the transition is invisible. No intermediates, no gradual evolution leading into complexity, just emptiness and then a flourishing. To some, this suggests an evolutionary bottleneck or catastrophic purge. To others, it hints at a transformation in environmental conditions. But growing numbers of researchers, especially those who study convergence between geology, biology, and planetary systems, see something deeper. A pattern, a rhythm, a before and after, a reset. The missing billion years may not be a void in the story of Earth. It may be the story, a point where the planet was reforged, where life was rerouted, where something new began that the previous world did not survive. And as we move deeper into this investigation, one question becomes impossible to ignore. Was this erasure a natural catastrophe or a deliberate rewriting of the planet itself? For now, we stand at the edge of the mystery. A vanished world behind us, a transformed world above it, and a billion-year silence lying between them like a wound in time. The Great Unconformity is both a boundary and an invitation, a line that asks us not just to study what was lost, but to understand why it was removed, and who or what may have shaped the world that came after. There are moments in Earth's history when the planet behaves not like a world shaped by steady natural forces, but like a surface struck by something overwhelming, something capable of wiping entire continents clean. The Great Unconformity is one such moment. To understand it, we must look not at what remains, but at what is missing. If you walk across ancient bedrock in places like the Canadian Shield, you will find surfaces that look unnaturally smooth, not smooth like erosion from centuries of wind or rain, but smooth like a deliberate scouring. These rocks bear the scars of forces strong enough to remove mountain ranges, river systems, entire ecosystems, and leave behind almost nothing. It is the geological equivalent of a reset button pressed with unimaginable force. Scientists have long suspected that something vast must have scraped Earth's surface during this lost interval, but the more closely they examine the surviving rocks, the stranger the picture becomes. The erosion is not random, it is not scattered, it is not chaotic like the aftermath of normal geological upheaval. It is patterned, it is synchronized across distant continents, and it reaches a depth that no ordinary process can easily explain. Consider glaciers. During snowball Earth episodes, ice sheets may indeed have covered the entire planet. Under miles of ice, rock can be ground down like material beneath a giant millstone. Ice is powerful, but ice alone cannot remove a billion years of geological history with the precision we observe. Ice scrapes downward, leaving behind deep channels, ridges, grooves, and piles of debris. Yet across enormous regions, the surface looks as though the debris itself was erased too, as if the planet cleaned up after the destruction. Supervolcanoes are sometimes proposed as the culprit. These eruptions can melt crust, destroy landscapes, and blanket continents in ash. But volcanism leaves signatures: hardened lava flows, volcanic glass, chemical markers. Those indicators are not present across the unconformity boundary in the consistent global pattern required for such a hypothesis. What about plate tectonics displacement, uplift, and subduction move crust around and recycle material into the mantle? But even the most violent tectonic forces do not neatly erase a billion years of sedimentary archive on every continent at once. What we see instead is a planetary surface that appears to have been stripped down, reset, and then rebuilt. A removal process so extensive that it touched nearly every corner of the globe. The question is no longer what caused erosion. Erosion is common. The true question is how erosion occurred everywhere at once, removing nearly the same span of geological time from places separated by oceans and continental masses. If Earth's history were a damaged painting, we would expect uneven decay. But the Great Unconformity resembles a deliberate scraping, as though someone dragged a blade across the canvas, removing the pigment in a single controlled motion. Some geologists have proposed that the missing record may be the result of a long interval of exposure. In other words, continents may have risen above sea level and remained exposed for hundreds of millions of years, allowing wind and water to wear them away. Yet this idea suggests a slow, gradual process. But the boundary we observe is sharp, not gradual. The transition does not fade like weathering over eons. It slices down into deep time with a distinct, almost mechanical edge. This abruptness is the part that refuses to fit into conventional explanations. Even more unsettling is the discovery that many unconformity boundaries show evidence of chemical alteration. Some of the exposed surfaces have been stripped not only of rock, but of their mineral identity. The chemistry hints at reactions requiring immense pressure, extreme temperature, or fluids that do not align with typical Earth processes. It is almost as if the crust was cleansed, not just eroded, as if something removed what had been there and left behind a fresh surface, ready for whatever came next. There are regions where the boundary looks like a polished platform. Other places show fractures that formed simultaneously across vast distances, as though the crust experienced a global stress event. There are even cases where younger rocks rest directly atop ancient crystalline basement with no intermediate layers at all. It should be impossible for so much time to disappear without a trace. And yet here it is, a billion years gone. The deeper scientists probe this boundary, the more it resembles an effect without a cause, a disturbance without a clear mechanism. It is geological evidence of something powerful enough to coordinate destruction on a planetary scale, to reach every continent, to reset Earth's surface, and to do so with a precision that is difficult to reconcile with natural processes alone. But if this was a natural catastrophe, then why is the erasure so eerily synchronized? Why does it appear to have removed only the interval preceding the rise of complex life? Why does the gap correspond so closely with the moment life prepares to advance into its most dramatic evolutionary leap? And perhaps most intriguing of all, why does the unconformity sometimes preserve features beneath the surface that should have been destroyed if erosion alone were responsible? In some regions, ancient weathering profiles remain intact beneath the boundary, suggesting that erosion did not simply strip away sediments, It selectively removed specific layers and preserved others. That selectivity is one of the great unsolved puzzles. Natural processes do not filter history this carefully. As we examine this missing chapter, the planet begins to look less like a world shaped by slow, random forces, and more like one that experienced an organized restructuring. A global renovation, a controlled demolition of the old world, followed by the construction of a new biological stage. Some researchers whisper theories not yet accepted in mainstream geology. The idea that Earth may have undergone an event engineered by physics we do not understand. A shift in environmental conditions beyond anything recorded since. A planetary cleansing triggered by processes either internal and catastrophic or external and deliberate. Whatever caused the erasure, it set the stage for a transformation unlike anything seen before. And when the reset ended, the world that emerged was not the same as the one that vanished. The biosphere was ready to explode into complexity. The Earth had been scraped clean. The question now is whether we are looking at the aftermath of disaster or the beginning of design. If the Great Unconformity were only a story about missing rock, perhaps it could be dismissed as a geological inconvenience. But its true weight emerges in what comes next, because the moment the billion-year silence ends, the fossil record erupts with something so sudden, so dramatic, that it defies the expectations of evolution itself. This moment is known as the Cambrian explosion, a phrase that sounds exaggerated until you realize how abrupt the change truly is. For billions of years, life on Earth was simple. Single cells drifting in ancient oceans, microbial mats clinging to shorelines, filament-like structures barely perceptible in layered stone. The world was quiet, repetitive, almost uneventful. And then, without warning, the curtain rises on an entirely different planet. Creatures with eyes, creatures with jaws, creatures with shells, spines, muscles, articulated limbs, complex digestive systems, and sophisticated sensory organs. Predators appear for the first time. Prey evolves to escape them. Nervous systems flourish. Entire ecosystems emerge from nothing, fully formed and unquestionably functional. It is not a climb. It is a spike, not a transition, a transformation. Evolution is a slow sculptor, carving forms through incremental change over immense spans of time. Yet here, in the layers immediately above the missing billion years, we see forms that look nothing like their microbial ancestors. There are no half-developed tissues, no partially evolved organs, no intermediate shapes caught in the struggle between possibility and failure. Instead, the fossil record shows diversity exploding in every direction. Complexity appears abruptly, like someone switched on a biological engine. Scientists have spent decades trying to explain this moment. They search for gradual steps in older rocks. They pore over microfossils hoping to find the precursors of eyes, limbs, or shells. They adjust timelines, refine radiometric dates, and reconsider environmental conditions. But the gap persists. The fossils remain silent, and the biological leap remains astonishing. At first glance, it seems as though the reset removed not only Earth's geological memory, but also erased the gradual steps life would have taken toward complexity. Yet this possibility raises its own question. If those steps were erased, why do we not find fragments of them preserved elsewhere? Instead, everywhere we look, the pattern is the same. Silence, then explosion. Simplicity, then complexity. A world erased, then a world reborn with astonishing speed. It is this timing that frustrates conventional explanations. Consider eyes. Visual organs are not trivial structures. They require photoreceptors, neural networks, lenses, and signal processing capabilities. Yet they appear rapidly in Cambrian animals. Consider shells. They appear suddenly too, despite requiring biochemical pathways to extract minerals and structural genes to shape them. And consider mobility. Early Cambrian predators exhibit coordinated movement, muscular control, and feeding mechanisms that imply long periods of evolutionary refinement. But where is that refinement in the record? It is missing. It was removed. Or it never existed in the first place. Some researchers propose environmental triggers. Increased oxygen, changing ocean chemistry, or rising nutrient levels may have enabled rapid diversification. These explanations offer pieces of the puzzle, but they do not address the deeper question. Even with improved environmental conditions, complexity does not appear instantly. It must first be built, unless it was already built somewhere else. Somewhere in the missing time. Somewhere in the vanished world erased by the Great Unconformity. This is where the story deepens, because if life during the missing billion years had already evolved hidden forms of complexity, then the Cambrian explosion may not represent the origin of complex life. It might represent its return. What if life did not evolve complexity after the reset, but brought suppressed complexity forward once conditions stabilized again? What if multicellular organization existed in the erased world, only to be wiped out and forced to re-emerge in a new planetary environment? If so, the Cambrian explosion is not a beginning. It is a recovery. A restoration of biological potential after a catastrophe severe enough to strip the Earth's surface clean. Some scientists reject this idea because it implies that evolution took place in a time that left no fossils. But that is precisely the problem. If the Great Unconformity destroyed the geological archive of that time, then the absence of fossils proves nothing except that the erasure was complete. This leads to a troubling interpretation, one that few dare to voice openly, that perhaps the timing is not coincidental, that perhaps the reset and the emergence of complex life are connected not as cause and effect, but as two phases of a single process. First phase, erase the old world. Second phase, introduce or awaken the new one, but awaken from what evolutionary potential coded within ancient microbial lineages. Genetic programming waiting for environmental cues. Dormant genomes triggered by planetary conditions we do not yet understand. These possibilities stretch the boundaries of biology but are not impossible. However, there is another interpretation, one even more controversial. Some propose that the Cambrian explosion looks less like natural evolution and more like a deployment, as if biological systems were introduced rapidly once the planetary environment reached a stable threshold, as if something or someone pressed start on a new biological era after the reset was complete. Mainstream science does not support such ideas. Yet when faced with a billion years missing, a global geological purge, and a sudden burst of complexity that appears from nowhere, speculation becomes difficult to avoid. The data do not tell a simple story. They tell a story that refuses to sit comfortably within the traditional narrative of gradual evolution. What we can say with certainty is this: the timing matters. The erasure ends exactly at the moment complexity begins. The planet is cleared, and immediately life becomes something it was not before. It is a before and after boundary so sharp that it feels intentional. As we move forward, we will examine the survivors of the erased world, preserved not as fossils, but as chemical ghosts locked inside ancient crystals. And we will confront the possibility that life during the missing time may have been stranger, more advanced, and more resilient than anything in the Cambrian seas. But before we do, one question remains suspended in the silence of deep time. Did complex life emerge because Earth was reset, or was Earth reset so that complex life could emerge? If the rocks themselves refuse to tell the story of the missing billion years, then perhaps the truth survives in something far smaller, something resilient enough to endure destruction on a planetary scale, something capable of trapping fragments of ancient worlds inside its crystal lattice. This is where zircon enters the story. Zircon grains are tiny, some no larger than a grain of sand, yet they are among the most durable materials on Earth. They form deep within the crust under intense heat and pressure, and once created, they can survive erosion, burial, uplift, and even the repeated cycles of destruction that shaped the early planet. Zircons endure what entire continents cannot, and inside them, sealed away like microscopic time capsules, lie the chemical signatures of a world long vanished. When researchers began studying zircons taken from regions close to the Great Unconformity, they expected to find only the chemical fingerprints of molten rock. Instead, they found carbon isotopes and trace patterns that should not exist within purely geological material. Ratios that hint at biological activity, signals suggesting that life was operating during the very period that is absent from the geological record. These crystals should not contain evidence of life, but they do, and this raises a question more profound than any puzzle presented by missing rock. If life existed during the erased era, then what kind of life could survive in conditions so extreme that they destroyed nearly everything else? The zircon signatures point to something unusual. They suggest biological processes that occurred at temperatures far beyond what modern organisms can tolerate. Some patterns hint at metabolic cycles unlike anything seen in current ecosystems. Even more puzzling, the chemical traces appear consistent across zircons from widely separated regions, implying a global biosphere that operated under conditions we barely understand. This is the first real glimpse into the world that disappeared. Not fossils, not bones, not organisms, but chemistry. A ghost-like residue of a biosphere that was stripped from Earth's surface long before it had a chance to leave recognizable forms. The more we study these zircon grains, the clearer it becomes that the lost world was not a barren place. It was active, dynamic, possibly thriving. And then something happened that ended it so completely that only microscopic clues remain. But zircons contain more than signs of life. They also record the environment in which they formed, and what they reveal about those conditions is deeply unsettling. Temperatures fluctuating wildly, oceans appearing and disappearing in rapid cycles, atmospheric shifts so intense they would be lethal to most modern organisms, chemical gradients that suggest oceans rich in dissolved metals and reactive compounds, a magnetic field that flickered unpredictably, radiation levels that would sterilize today's ecosystems. This was not a stable world. It was a world in chaos. Yet life was not only present, but may have adapted to conditions we would consider impossible. Some scientists believe the biosphere of this era may have been fundamentally different from ours, perhaps based on alternative metabolic pathways, perhaps capable of tolerating extremes that would destroy modern life, perhaps existing in forms that do not fossilize or that decomposed so completely during the reset that no macroscopic evidence remains. This idea challenges our assumptions about what life is supposed to look like. It suggests that the erased biosphere may not have been simpler than ours, but simply different, unfamiliar, alien not in origin but in design. Life shaped by forces and environments we no longer see on Earth. One detail stands out in the zircon data. It appears that some biological signatures vanish suddenly across samples from around the same time, not gradually, not fading out through natural decline, but abruptly, as if the biosphere was switched off, as if the conditions that sustained it were removed in an instant, as if a boundary was crossed and the old world could not survive on the other side. This adds weight to the idea that the Great Unconformity was not simply erosion. It may have been the final stage of a sequence of global transformations that began deep within the planet or far beyond it. A cleansing, a reset that did not merely remove rock, but eliminated an entire ecosystem. The abruptness troubles researchers because natural extinctions leave traces. Declines, transitional species, chemical gradients indicating environmental stress. Yet here, none of that appears. Instead, we see signs of life, then silence. Then, after the unconformity ends, a new biosphere emerges bearing no clear relationship to the one before. It is a severed lineage, a broken continuity, a restart. And that raises a question that few dare to articulate aloud. Did life during the missing billion years evolve into complexity that we cannot recognize? Did it develop forms and systems not preserved by the crust? Did it experiment with pathways that later vanished without leaving descendants? Or is the reason the old biosphere left no trace far more radical? Perhaps the erased world and the world that followed are not part of the same evolutionary chain. Perhaps the ancient life recorded in zircons was never meant to lead to the organisms that dominate Earth today. Perhaps the reset was a turning point, a pivot, a deliberate removal of what existed to make way for something new. This possibility invites speculation that borders on the uncomfortable. It suggests that the missing billion years were not only lost, but intentionally overwritten. That the world after the reset was not a continuation, but a replacement. And if so, then the zircons become more than scientific tools. They become relics of a world that Earth itself abandoned. What kind of planet erases its own biological past? What kind of event has the power not only to destroy a biosphere, but to restructure the conditions necessary for life itself? And most importantly, what drove this transformation? Was it catastrophe, coincidence, or something encoded in the planet from the beginning? The tiny crystals do not answer these questions, but they deepen the mystery. They reveal that the erased world was rich with processes we barely comprehend. And they remind us that whatever happened during the missing billion years was not a simple natural shift. It was a transition, a boundary, a change so profound that it did not just wipe away life. It created the conditions for an entirely different world to rise in its place. If the missing billion years held a living world, then its presence should echo somewhere beyond chemical residues trapped in crystals. And it does. Not through fossils, not through bones, but through something far more mysterious. Structures that should not exist, traces that should not form, empty shapes that resemble life only in their absence. Scientists call them ghost fossils. They are not fossils in the traditional sense, they are voids. Hollow spaces within rock where something once existed, but where the material itself has dissolved so completely that only its outline remains. It is as though a living form pressed itself into the stone and then vanished, leaving behind the negative imprint of a creature we cannot fully imagine. These voids do not resemble creatures from the Cambrian seas. They do not resemble anything known from the fossil record. They are geometries, patterns and forms that suggest biological complexity, but without any recognizable anatomy. No shells, no limbs, no bones, but something was there. Something with structure. Something that left a shape before being erased from the world. The existence of ghost fossils suggests a biosphere that developed along an evolutionary path distinct from our own. A world of organisms built from materials that did not survive the reset, shapes that chemical weathering could dissolve without a trace. Biologies that decomposed beyond the reach of preservation. If life from this era lacked mineralized tissues, then it might leave no conventional fossil record at all. But ghost fossils tell us that something lived, something organized, something more than microbial mats drifting across shallow seas. The few shapes preserved in ghost form suggest networks, branching structures, layered tissues, and fractal patterns that seem too complex to belong to single-celled organisms, yet too alien to match anything in modern biology. Some appear filament-like, but with repeating internal segments. Others look like flattened ribbons with ridges arranged in mathematical sequences. A few resemble no existing life form, but instead look engineered in their precision, as if shaped by rules that differ from anything known on Earth today. And then abruptly, they disappear. They do not decline. They do not transition. They end. Ghost fossils vanish from the rock record just as abruptly as the billion-year gap begins. Across the world, the shapes of this forgotten biosphere cease. The boundary where they should continue is blank. No gradual fading, no evolutionary shift. A sharp and final cutoff. Whatever lived during the missing billion years did not simply go extinct, it was erased. This raises an uncomfortable possibility. The Great Unconformity may not have been a passive erosion of rock. It may have been the last stage of a global transformation that eliminated an entire ecosystem from the face of the planet. A purge so complete that only the hollows in which organisms once lay remain as silent witnesses. Why did the first biosphere end so abruptly? Was it an environmental collapse? Did rising oxygen levels overwhelm organisms adapted to low oxygen conditions? Did changes in ocean chemistry dissolve their bodies faster than they could fossilize? Or was it something else entirely? Some researchers see the sudden disappearance as a signature of a catastrophic event, a threshold crossed, a system reset. They imagine a world where ancient oceans drained or froze, where the crust upheaved, where mantle processes tore the planet open. But these explanations struggle to account for the global consistency of the vanishing, and they cannot explain why no transitional forms bridge the erased world and the one that followed. Others take an even more radical view. They argue that the pre-Cambrian biosphere was not meant to lead to modern life, that it represented an evolutionary experiment that reached its limit, a divergent path that failed under environmental stress and was replaced by a new lineage better suited for a changing planet. This idea suggests a branching of life that ended not at the Cambrian explosion, but long before it. Our world may be only the latest in a series of biological eras, each rising and falling across deep time. If so, the ghost fossils are the only memorial to a vanished chapter, a world whose descendants were denied a future. Yet the most thought-provoking interpretation considers the possibility of replacement. The sudden absence of the first biosphere, followed immediately by the emergence of complex life, challenges the idea of continuity. It suggests a disruption to evolutionary flow, a break so absolute that the new world seems independent from the old. It is as though the Earth was wiped clean to prepare for something radically different. Not because the previous biosphere failed, but because the planet itself was entering a new stage. Higher oxygen levels, greater tectonic movement, changing climates, shifting oceans, environmental forces that demanded new biological tools, new structures, new strategies. The old world may have been incompatible with the coming one, and so it ended, leaving behind only faint impressions as the last evidence of its existence. There is a subtle but haunting implication here. If the old biosphere was erased, and the new one emerged swiftly afterward, then the transition was not purely biological, it was environmental, geological, and perhaps even systemic. Something about the Earth itself changed in a way that favoured new life forms and eliminated the old ones. This raises questions that ripple far beyond paleontology. Was this transformation inevitable, a natural cycle in the long evolution of planets, or was it triggered by forces deeper within Earth's interior, or did it involve influences from beyond the planet altogether? The ghost fossils cannot answer, but their silence is telling. They reveal that what existed before the reset was not a primitive world inching toward complexity, but a world complete in its own way. A world with its own evolutionary trajectory. A world that did not give rise to us, which leads to an unsettling thought. If Earth once hosted a biosphere completely separate from our own, how many others may have risen and fallen before it? Is life on this planet a sequence of chapters rather than a single continuous story? Are we living in the third act of a drama that began long before the fossils we study? Or is this only the beginning of understanding how many worlds have come and gone on the same planet beneath our feet? The ghost fossils linger as quiet reminders, shapes without bodies, memories without voices. They hint at a world that vanished not slowly but suddenly, as if erased by a force that reset not simply the landscape, but the very direction of life itself. What kind of event could end an entire biosphere in a single stroke? And what kind of transformation could rise in the silence that follows? There are moments in planetary history when the world does not simply shift, tilt, or quake, but transforms so profoundly that it becomes something new. Moments when the crust, mantle, oceans, and atmosphere reorganize themselves in movements so violent that the planet seems to turn itself inside out. If the Great Unconformity represents a reset, then one of the most extraordinary ideas proposed to explain it is known as Crustal overturn. At first, the concept sounds impossible. The entire outer shell of the Earth, the rigid crust that carries continents and oceans, pulled downward into the mantle, while deeper layers rise upward to the surface. But in the chaotic early history of Earth, when internal heat was far greater and the crust was thinner, more fractured and more mobile than it is today, an overturn event may not only have been possible, but inevitable. To imagine a crustal overturn, picture a planet where the internal forces pushing upward and downward reach a point of crisis, a threshold. Pressure builds, heat accumulates, fractures spread across the crust in patterns spanning entire continents, and then, in a geologic instant, the surface collapses downward while deeper material rises to replace it. If such an event happened, it would not simply alter the landscape, it would annihilate it. Mountains would sink, oceans would drain or vaporize, sediments would be destroyed, entire layers of crust would be drawn down into the mantle and melted away. Evidence of biological activity would vanish. The surface would be reset to a blank state, stripped of the record it once held. This is exactly what the Great Unconformity resembles. There are regions where deeply buried crystalline rock suddenly appears at the surface, as though continental interiors were exhumed without the slow processes of erosion and uplift. In other regions, the oldest rocks lie directly beneath much younger layers without transitional strata. This is the signature of removal, not gradual change. Clues supporting the overturn idea come from mineral structures that bear marks of extreme pressure and temperature changes, far beyond what normal surface processes could produce. They reveal cycles of heating and cooling that do not align with volcanic activity or regional metamorphism. Instead, they suggest a global disturbance, a massive recycling of crust. If the Earth truly turned itself inside out, the impact on any existing biosphere would have been catastrophic. The oceans, with all their microbial life, would have boiled or frozen depending on the location. Superheated fluids would have surged across fault lines. Toxic gases would have filled the atmosphere. Radiation levels near the surface would have spiked as magnetic fields faltered. No known organism could survive such widespread devastation. This is the kind of event that does not simply cause extinction, it causes erasure. A crustal overturn would have removed the bulk of the pre-existing sedimentary layers, dragging fossils, organic material, and geological archives back into the mantle. It would explain why the missing billion years vanish with such surgical precision, why the boundaries between the old world and the new are so sharp, and why the story of the first biosphere ends so abruptly. It also explains something else, why the world that emerges after the reset looks so dramatically different, why oxygen levels rise, why ocean chemistry changes, why tectonic systems reorganize, why life explodes into new complexity. If the planet reorganized itself from the inside, everything built on top of it would begin again. But the idea of a crustal overturn carries implications beyond simple destruction. It suggests that Earth's evolution is not a smooth ascent, but a sequence of revolutions, a cycle of renewal that reshapes the physical and biological world together. Some geophysicists argue that overturns may happen when heat trapped beneath the crust reaches a critical threshold, building up for millions of years before releasing in a single world-altering event. If this is true, then the Great Unconformity marks not only a geological boundary, but a turning point in the life of the planet, a moment when Earth became a different world, both physically and biologically, a moment where the past was peeled away to make room for the future. Yet there is a troubling aspect to this idea. Even if crustal overturn explains the destruction of the ancient biosphere, it does not explain the timing. Why would an overturn occur just before the emergence of complex life? Why did the planet reorganize itself at the exact moment when biology was poised to change forever? Some argue that the overturn itself triggered the rise of complexity, that the new environment created by the restructured planet offered opportunities for evolutionary innovation, that new oceans, new coastlines, and new chemical gradients allowed life to flourish in ways not possible before. Others take a more provocative view. They suggest that the crustal overturn may not have been an accident of internal heat. Instead, it may have been a response, a forced transition triggered by external forces or by systemic thresholds built into the planet, a kind of planetary reset mechanism activated when certain conditions were met. This idea is controversial, but it aligns with the suddenness of the geological boundary. It also aligns with the silence of the fossil record before the Cambrian explosion. And it resonates with the idea that the Earth, like any complex system, may undergo phase shifts when pushed beyond certain limits. If the crustal overturn was a natural cycle, then we may be witnessing only one chapter in a repeating story. If it was triggered, then the missing billion years take on a new meaning. They become not only a lost world, but a precursor to transformation, a prelude to the era of complexity. And here another question emerges. If Earth once turned itself inside out, is it possible that other worlds have done the same? Have planets across the solar system endured similar resets? Have other biospheres risen and fallen on distant worlds through comparable cycles of creation and destruction? The Earth may not be the only planet with a past it has erased. If this is true, then the Great Unconformity is not just a geological anomaly, it is a clue, a sign that Earth participates in a larger pattern, one that may repeat across worlds, one that may shape not only continents but life itself. And if other planets show similar scars, then the mystery of the missing billion years may extend far beyond Earth's boundaries. For most of scientific history, the Great Unconformity was treated as an earthbound mystery, a geological riddle confined to our continents and oceans. But as spacecraft began exploring neighbouring worlds, something unexpected emerged. The scars of planetary reset, once thought unique to Earth, began appearing in places where no erosion, rain, or biological activity could explain them. Evidence from Mars, Venus, and even the moons of the outer planets started to shape a picture far more unsettling than anyone anticipated. The more we looked outward, the more familiar the patterns became. On Mars, layered sedimentary deposits show sudden interruptions. Entire epochs appear missing, replaced not by gradual transitions but by abrupt boundaries. In some regions, the Martian crust displays a sharp contact between ancient bedrock and much younger volcanic plains, with an absence of intermediate layers. It resembles the same break seen in the Great Unconformity, though shaped by different forces. This is not erosion by water. Mars lost most of its oceans long before these discontinuities formed. Nor is it volcanic resurfacing alone, because the younger plains overlie surfaces that show signs of prior stripping. Something removed entire sections of Martian history before lava flows filled the emptiness. Then there is the question of the Martian magnetic field. Billions of years ago, Mars possessed a strong magnetic shield, much like Earth. But then suddenly, it collapsed. Without it, the atmosphere thinned, water evaporated, and the surface became hostile. The timing of this collapse aligns suspiciously with some of the missing geological record. It suggests not just surface change, but a planetary system failure that altered Mars from the inside out. If Earth underwent a reset, then Mars may have endured something even harsher. A collapse not only of crust but of global protection, stripping the planet of the conditions that might once have supported a richer biosphere. The absence of life on Mars today does not prove it never existed. It may simply mean it did not survive the event that transformed the planet. Venus tells an even stranger story. Radar images reveal a surface that appears extraordinarily young. The entire crust of Venus seems to have been resurfaced in a single catastrophic episode. Craters of all ages are missing. Geological features appear flattened, melted, or overwritten. There are no ancient mountains left, only the shapes carved by more recent activity. Some scientists argue that Venus may have been completely resurfaced about 500 million years ago, replacing its ancient crust with a fresh one. This is the Venusian equivalent of a planetary reset, a world wiped clean. Why would Venus undergo such an event? On Earth, plate tectonics slowly reshapes the crust, releasing internal heat through steady motion. But Venus lacks plate tectonics. Instead, heat builds beneath its rigid shell until the pressure becomes unbearable. Some researchers believe the crust then ruptures catastrophically, releasing heat in a single planet-wide outpouring of lava, a geological purge. If true, Venus did not gradually evolve into the inferno we see today. It may have transformed in a single violent moment, resetting its entire geological record. A reset not unlike the Great Unconformity, only far more extreme. Even the icy moons of the outer solar system show patterns that echo this cycle of destruction and renewal. Europa and Enceladus exhibit fractured surfaces where older ice is replaced by younger sheets. Some regions display missing intervals, suggesting episodic resurfacing driven by subsurface oceans and tidal forces. Again and again, we see worlds that have erased their own past. As these discoveries accumulate, a provocative idea begins to emerge. Perhaps Earth's missing billion years were not caused by a unique terrestrial catastrophe. Perhaps planetary resets are common. Perhaps they are part of a wider pattern across the solar system. This idea challenges the assumption that planetary evolution is stable and gradual. It suggests instead that worlds undergo cycles of transformation driven by internal thresholds or external triggers. That planets can reorganize themselves in sudden shifts. That life, if present, must either adapt or vanish. But the most troubling aspect of this pattern is the timing. When researchers compared the approximate ages of major resurfacing events on Venus and Mars with the timeframe of Earth's Great Unconformity, they found potential overlaps. Not perfect, not identical, but close enough to raise eyebrows. Enough to suggest that multiple planets may have experienced severe upheaval within the same broad window of time. Could a single cause affect entire worlds at once? A sequence of asteroid bombardments? A solar outburst powerful enough to destabilize planetary systems? A gravitational disruption from deeper in the solar system? Or something even more unusual? We do not know. What we do know is that the solar system was not calm during the period of Earth's missing billion years. Giant impacts were still shaping planets. Massive amounts of debris still drifted between worlds. The young sun cycled through volatile phases that would dwarf today's solar storms. The entire system may have passed through interstellar regions dense with radiation or gravitational turbulence. Under such conditions, multiple planets could experience resets through different mechanisms but triggered by the same cosmic influence. If so, Earth's erasure is not an isolated puzzle but part of a chain reaction. A solar system-wide transformation that altered the futures of several planets. Mars may have lost its magnetic field. Venus may have overturned its crust. The icy moons may have fractured and frozen anew. And Earth may have scraped away its ancient surface and prepared for a new era. This raises a profound question. If multiple planets suffered resets, why did Earth become the one to host complex life afterwards? Why here? Why now? Why us? Perhaps Earth's reset was less destructive than the one on Venus. Perhaps our magnetic field did not collapse like that of Mars. Or perhaps Earth's reset was not an accident at all, but an event that created the exact conditions necessary for complexity to bloom. And if that is true, then the missing billion years may be more than a mystery. It may be a turning point not only in Earth's history, but in the history of the solar system itself. A moment when worlds were reshaped. A moment when futures diverged. A moment when Earth became something new. And as we look deeper into these patterns, another possibility emerges. one that suggests life may not simply endure planetary resets, but may be shaped by them in ways we are only beginning to understand. If the Great Unconformity reset the planet and stripped away an entire biosphere, then the world that followed should have been empty, sterile, and biologically barren. Yet the opposite occurred. The moment Earth stabilized after its mysterious erasure, life did not simply return. It re-emerged with new sophistication, new complexity, and new patterns of organization never seen before in the geological record. It is difficult to ignore the timing. The absence of fossils below the boundary, the sudden richness above it. The geological reboot immediately followed by a biological awakening. It raises a question that reaches beyond the Earth itself. If the reset prepared the planet for something new, then where did that something come from? To answer this, we look not downward into the rock, but upward into the sky. For the first time in Earth's history, complex genetic systems appear with astonishing speed. DNA coding for intricate multicellularity, gene families that enable movement, digestion, respiration, and sensory perception, regulatory networks that coordinate thousands of biological processes at once, all appearing without the long prelude expected from slow evolutionary development. Some researchers describe this as a second genesis, a reboot not only of geology but of biology, a moment when the planet transitioned from simple microbial existence to a world primed for animals, ecosystems, and eventually consciousness. The theory of Panspermia offers one possible explanation. It proposes that life, or the raw ingredients of life, may travel between worlds, carried on comets, asteroids, dust grains, or even interstellar debris. This idea once belonged to the fringes of science, but recent discoveries have brought it into mainstream discussion. We now know that organic molecules are common in space. They appear in meteorites, in comets, in nebulae, and in the atmospheres of distant planets. Complex carbon chains are found drifting between stars. Even amino acids, the building blocks of proteins, have been discovered in meteorites that landed on Earth. If Earth's early oceans received these molecules long before the reset, they may have contributed to the first genesis. But if they arrived after the reset, they could have seeded the second. Yet Panspermia alone does not fully explain what we see. The sudden organization, the rapid emergence of functional body plans, the well-coordinated systems that appear ready to operate without long evolutionary ramps. This is where the concept of directed panspermia enters the discussion. It suggests that life may not simply drift through the cosmos by chance, but might be distributed intentionally or semi-intentionally by natural cosmic processes that favor the spread of biology. Stars, planetary collisions, or interstellar currents may create pathways for biological transfer. Under this view, life becomes not an isolated accident, but a cosmic tendency, flowing along gravitational and chemical channels across vast distances. Such a mechanism could explain why complex genetic systems show up so abruptly after the Great Unconformity. If the planet reset itself, or was reset by external forces, then the new Earth might have received fresh biological material from beyond its boundaries when conditions became favorable. This idea becomes even more compelling when we consider that the DNA of modern organisms contains deep molecular patterns that appear older than the Cambrian explosion. Some genetic structures seem to predate the fossils in which they first appear. In fact, they seem to come from nowhere in the geological record, as though inherited from ancestors we cannot see. Could those ancestors have lived during the missing billion years? Could they have existed elsewhere in the solar system? Or could they have originated beyond Earth entirely? There is another layer to this mystery. After the reset, oxygen levels rose steadily. The chemistry of the oceans shifted. Nutrients circulated differently. These changes would have created a new biological opportunity, one that may have allowed incoming genetic systems to flourish where old forms perished. It is possible that the first biosphere was simply incompatible with the environment that followed the reset. but the genetic systems that emerged afterward were perfectly suited for it. Too perfectly, some argue. This leads to a provocative question. Did Earth receive not only raw organic molecules, but entire genetic frameworks during or after the planetary transformation? Did the reset clear the planet so thoroughly that it became a clean slate on which new biological possibilities could take root? Such an event would resemble a software wipe followed by the installation of a new operating system. A planetary erasure followed by a biological upload. There is no direct evidence that life arrived packaged or organized, but the speed with which complexity appears and the absence of transitional fossils make the idea difficult to dismiss outright. And if Earth was not the only planet undergoing drastic changes at the time, as evidence from Mars and Venus suggests, then the entire solar system may have been part of a larger biological cycle. Some scientists propose that the solar system itself may function as a kind of incubator. Worlds rise, fall, and reset. Conditions shift. Biological material drifts between them. And when one planet becomes suitable for a new biological phase, life arrives, whether by chance or by the inherent tendency of living systems to spread. If this view is correct, then the missing billion years may not represent a single biosphere, but multiple ones. A succession of biological eras, each shaped by events that determine which forms persist and which vanish. Earth may be only the latest in a long chain of worlds to host life, and our biosphere may carry echoes of ancient systems long lost to time. This idea brings an unsettling possibility into focus, that evolution on Earth is not entirely isolated, that our lineage may trace back to sources we have never seen, that life on our planet may belong to a larger cosmic story, one that stretches between stars. And if life can travel between worlds, then the boundary of biology does not end at Earth's atmosphere. It extends outward into the solar system and perhaps far beyond. This raises another question. If life arrived after the reset, then was Earth chosen by chance or chosen by design? A world cleared, prepared, and seeded with potential ready to unfold into the complexity that defines the Cambrian explosion. The answer remains unknown, but the patterns we observe suggest that biology may be more mobile, more resilient, and more interconnected than we ever imagined. And as we look deeper into the geological and chemical records, we will encounter evidence that the reset did not only prepare the planet for life, it may have prepared it for something else, hidden not in fossils, but in minerals that should not exist at all. If the story of the Great Unconformity were only one of missing rock, missing life, and missing time, it might still be explained within the boundaries of natural processes. But the deeper researchers dig into the mineral records surrounding the missing billion years, the more perplexing the evidence becomes. Not because of what is gone, but because of what remains. Because inside the rocks forged during the periods before, during, and after the planetary reset lie structures that seem to defy the known limits of nature. They are called high-pressure polymorphs, shock-formed minerals, and anomalous crystalline matrices. They appear in places where they should not form. They contain materials that should not coexist, and their internal patterns suggest they were shaped under conditions far beyond those produced by normal geological activity. Some of these minerals require pressures so extreme that they should only form deep within the mantle, miles beneath the crust. Yet they are found at or near the surface, embedded within rocks that should never have experienced such forces. Others contain gas inclusions with chemical signatures that do not match Earth's atmosphere at the time they formed. A few contain isotopic ratios that suggest processing at temperatures far higher than volcanic activity could produce. This is not random. These minerals appear precisely around the geological boundaries associated with the Great Unconformity. It is as though the planet underwent a process so violent, so transformative, that minerals were forged in conditions that mimic industrial or mechanical processes. Conditions that resemble the chambers of high-pressure reactors rather than the slow drift of tectonic plates. Take, for example, stishovite, a rare mineral that forms under pressures far higher than those found in normal crustal environments. It is usually associated with meteor impacts, but in some unconformity zones, it appears without any evidence of an impact crater. No shocked quartz, no breccia, no melt sheet, just stishovite appearing in isolation as if created by forces that did not originate from the sky. Or consider the presence of cubic zirconia like structures in ancient rocks. Not the synthetic material used today in jewelry, but natural crystalline formations that resemble them so closely that their existence has long puzzled researchers. They require not only high heat, but extremely rapid cooling, an unnatural combination rarely found outside experimental laboratories. Even more puzzling are minerals that show layered microstructures resembling engineered composites, thin films of alternating materials that form repeating patterns. These patterns do not match sedimentary layering or metamorphic banding. Instead, they resemble the kind of layering seen in advanced materials science, almost like the planet briefly became a factory of heat, pressure, and controlled crystallization. In some samples, crystal lattices show defects arranged in repeating geometric formations. Natural crystals form defects, yes, but not in ordered arrays. Not arranged in patterns suggesting directional forces. Not in ways that can be mathematically modeled as if they were shaped by intention rather than randomness. These mineral anomalies raise a disturbing possibility. If the Earth experienced a crustal overturn or planetary reset, then the forces involved may have exceeded anything we traditionally attribute to natural processes. The planet might have undergone momentary conditions that mimic artificial engineering, conditions capable of forging minerals that look manufactured. But another possibility lurks in the background, one even more controversial. Perhaps these minerals do not merely resemble engineered materials. Perhaps they are engineered materials. Traces of ancient tools or technologies would not survive a planetary reset. Metal, alloys, and artifacts would be destroyed by melting, pressure, and chemical dissolution. Yet the materials they produced might leave behind signatures, unusual structures, synthetic-like patterns, unexpected crystalline formations. The mineral record becomes, in a sense, the last place where evidence of an advanced process might remain. It is important to clarify that no scientist claims these minerals are proof of ancient technology, but many acknowledge that the conditions required to form them stretch the boundaries of what we consider naturally plausible. They appear in environments lacking the known triggers for such transformations. They show patterns inconsistent with chaos. They appear globally across different continents in a way that suggests a synchronized event. One could argue that the reset unleashed forces similar to those used in experimental material synthesis. If the crust collapsed or overturned, if magma surged upward under enormous pressure before cooling rapidly, if the planet experienced internal compression waves, then minerals could have been forged in ways that mimic engineering. But even this explanation struggles with certain anomalies. For instance, some mineral inclusions contain noble gases in ratios that do not match any known atmospheric composition in Earth's history. Others contain microscopic traces of metallic elements arranged in ways that seem purposeful. And a few contain trapped microbubbles whose composition suggests chemical reactions not normally associated with geology. In one region, researchers identified a mineral that appears to have undergone controlled annealing, a process used in metallurgy to strengthen materials. Natural processes can anneal, but not with the consistency observed, not with the uniformity of temperature and pressure gradients seen in these samples. Such findings push the conversation toward uncomfortable terrain. If natural forces alone cannot fully explain these structures, then we are forced to consider alternatives. One possibility is that the Earth's interior was once far more active and complex than we realize, capable of producing bursts of energy and pressure beyond modern models. Another is that the solar system experienced external influences that altered planetary surfaces dramatically, creating mineralogical conditions we have not yet replicated. And then there is the idea, whispered in some scientific circles but rarely spoken aloud, that Earth may have undergone a kind of terraforming event, not in the science fiction sense, with machinery and intention, but in a deeper sense. A transformation of planetary conditions that left behind mineral signatures resembling engineered materials. A reset that was not only geological and biological, but chemical. If this is true, then the planet did not simply erase its past. It prepared its future. The minerals left behind would not be artifacts, but instructions. Records of how the world was rebuilt, clues encoded in the crystalline structure of the rocks themselves. It may sound impossible, but the minerals remain. They defy simple explanation, and they point to something extraordinary hidden within the fabric of the Earth, which leads to the next question. If minerals can store traces of the forces that reshape the planet, then could they store something else? Information, patterns, messages embedded in crystal. And if so, what were they meant to preserve? And who or what were they meant for? If the strange minerals surrounding the Great Unconformity challenge our understanding of planetary forces, then the crystals found within those minerals push the mystery even further. Because inside certain ancient stones, researchers are beginning to detect patterns that do not behave like the random imperfections of nature. They behave like information. Crystals grow according to the internal logic of chemistry. Atoms assemble into repeating structures. Defects occur unpredictably. Foreign elements are trapped in irregular ways. That is what should happen. But when scientists started scanning some of the anomalous minerals associated with the planetary reset, the defects were not irregular, the inclusions were not random, and the layers inside the crystals were arranged with a precision that felt eerily intentional. It began with a simple observation. Some crystals contained fractal patterns, not visual fractals carved on the surface, but fractal arrangements of atomic clusters repeating at multiple scales. Nature does form fractals, of course. Snowflakes, tree branches, lightning, river networks. But atomic fractals inside minerals are different. They require stability during formation, controlled variation in temperature, and precise timing during cooling. Too much fluctuation breaks the pattern. Too little fluctuation prevents it. The crystal fractals found in these ancient rocks display a level of symmetry and repetition that suggests a process maintaining delicate balance over extended periods, not the chaotic aftermath of planetary upheaval, something much more stable, something much more directed. Next came the discovery of banded layers inside certain crystals that appeared to record cycles, thin stripes of varying composition alternating in sequences that are mathematically predictable. At first, researchers assumed these layers recorded changes in environmental conditions, but the spacing between layers followed ratios characteristic of information encoding, ratios that mirror patterns in human-designed data structures, ratios seen in magnetic tapes, optical discs, and modern algorithms that compress and store information. These were not simple environmental archives. They looked like instructions. Of course, no one believes these crystals contain literal technological code, but the patterns suggest that the forces acting on them during their formation were highly ordered, not random. Something imprinted structure, something guided their shape, something wrote sequences into their lattice. This realization opened a new line of inquiry. Could the planetary reset have produced conditions capable of encoding information into minerals? Could massive waves of heat and pressure, combined with rapid cooling and internal convection, leave behind structured patterns that resemble data? It is possible, but the precision of the patterns challenges this idea. The transitions between layers are too sharp, the periodicity is too stable across different samples, and some patterns repeat across continents separated by vast distances, as if the same process acted globally, synchronizing crystal formation with remarkable consistency. Another discovery deepened the mystery further. In some crystals, atomic defects appear arranged in grids. Not perfect grids, but grids close enough to suggest an underlying force aligning them. This is profoundly unusual. Atomic defects should scatter randomly unless influenced by directional stresses or electromagnetic fields. Directional fields powerful enough to influence crystal formation on a planetary scale do not fit within our conventional models of Earth's interior during the time of the unconformity. But what if the reset unleashed forces unlike anything Earth has experienced since a crustal? Overturn, mantle surge, or magnetic reorganization might have produced temporary fields strong enough to leave imprint patterns. These fields could have acted like a writing mechanism, encoding instructions into the crystalline matrix during a moment of extreme transformation. In this sense, the crystals become archives not because someone placed information inside them, but because they recorded the process of planetary restructuring itself. Every stripe, every defect, every ordered layer might reflect the sequence of events that reset the planet. The crystals would not be messages, they would be memory. But some researchers push the idea further. They argue that the patterns look less like passive recordings and more like purposeful frameworks. They point out that certain crystals show branching sequences that resemble algorithmic decision trees. Others display nested hierarchies similar to error correction codes. Nature does not need error correction, but engineered systems often do. Could it be that the reset involved processes that behaved like algorithms, processes that followed stepwise sequences, adjusted variables, and stabilized outcomes? Nature can develop patterns that resemble computation. But could a planet reset itself using something that mimics computational behavior? This may sound extraordinary, yet the possibility aligns with emerging ideas in systems science. Complex systems, from star formation to biological evolution, sometimes self-organize in ways that look computational. They follow optimization pathways. They transition between states when thresholds are crossed. They restructure according to internal rules. If Earth is such a system, then the planetary reset might not have been a random catastrophe. It might have been the activation of a self-organizing protocol, a natural but highly structured process designed to maintain long-term planetary stability. Under this view, the crystal archives become the physical residue of that protocol, the geological equivalent of log files left behind by a process that reorganized the planet. But there is another possibility, one far more speculative, that Earth's early environment interacted with external forces that shaped its restructuring. Cosmic fields, solar outbursts, interplanetary interactions during periods of instability. If such forces influence crystal formation, then the sequences inside the minerals may reflect patterns originating beyond Earth. In this interpretation, the crystal archives contain more than planetary memory. They contain cosmic information encoded during the restructuring event, information that shaped not only geology, but the emergence of complex life that followed. Some crystals even show patterns that appear linked to biological processes, ratios resembling metabolic cycles, sequences matching the temporal spacing of cellular division, gradients that mirror the rhythms of respiration and energy transfer. It is as if the instructions for biological organization were present in the environment even before the Cambrian explosion, not encoded in DNA, but encoded in the planet. This notion is controversial, yet it offers a bridge between the geological reset and the biological transformation that followed. Perhaps the reset was not simply a destructive event. Perhaps it prepared the world for the arrival of complex life by restructuring its physical substrate, by aligning minerals, chemistry, and environmental conditions to support new forms of organization. If so, the crystal archives are not messages for us. They are foundational blueprints. They recorded the moment when Earth passed from one state of being to another, from the world before the missing billion years to the world that would ultimately give rise to consciousness. And if planets can leave such blueprints within their own minerals, then what else might they preserve? What other instructions remain hidden in stone? And what do they reveal about the next transformation the planet may be preparing for? If the crystal archives preserve the memory of a transformative event, then their patterns may hold something even more surprising. Not just a record of what happened, but a record of what is meant to happen again. Because across samples collected from distant continents, separated by oceans and billions of years of geological drift, one feature repeats with unsettling regularity. Cycles, layered sequences inside certain minerals, appear to track long-term oscillations in temperature, magnetic intensity, crustal movement, and chemical gradients. At first they seemed like the byproducts of environmental shifts, but the more researchers analysed them, the more apparent it became that the cycles are too consistent, too mathematically precise, and too globally synchronized to be random. Some patterns repeat every few million years, others every few 100 million, but one sequence stands above the rest, a massive cycle nearing 1.2 billion years in length. A cycle that appears to coincide with the early biosphere, the missing billion years, and the abrupt geological and biological reboot that followed. It is as though the planet operates on a cosmological clock, a clock that strikes only on rare occasions, a clock that resets not merely the crust or oceans, but the entire trajectory of life. If the Great Unconformity was one such reset, then the crystal archives may be revealing something profound. Instructions for the next one. Researchers studying magnetic signatures inside minerals have found that Earth's magnetic field strength fluctuates in a pattern that aligns loosely with the billion-year cycle. The reversals become more frequent near the beginning and end of these intervals. The core becomes unstable. The field weakens. Radiation levels at the surface increase. These signs are not perfect or conclusive, but they echo the kind of systemic thresholds expected in a major planetary shift. The same patterns appear in the chemistry of ancient oceans. Ratios of carbon and strontium suggest repeated collapses and recoveries of environmental equilibrium. Oxygen levels fluctuate in sweeping arcs. Some cycles end in mass extinction, others end in rapid expansion, but the largest cycle, the one approaching the billion-year scale, shows a boundary that aligns with the Great Unconformity. It is as if Earth needed to reboot itself to continue functioning. The idea is controversial. Planets are not machines. They are not programmed. And yet complex systems often behave like they are. They self-regulate. They adjust. They reorganize when pushed beyond their limits. Think of a forest fire, destructive yet necessary for renewal. Think of a star, collapsing inward until it ignites and stabilizes. Think of the human brain under extreme stress. At some threshold, it reorganizes its patterns to survive. Earth may be no different, a living system capable of shifting states when its internal conditions require transformative change. This interpretation gains support from a growing body of evidence suggesting that the billion-year cycle is not tied only to Earth. It may reflect larger astronomical rhythms, movements of the solar system through the galaxy, interactions with spiral arms, exposure to heightened cosmic radiation, changes in gravitational forces that subtly influence planetary interiors. If the solar system encounters regions of the galaxy that increase planetary stress, then the billion-year cycle may represent the periodic toll of cosmic influence, a rhythm imposed from outside, a reset triggered by the environment beyond our atmosphere. But there is a darker possibility that the resets are not merely responses, but preparations. That the cycle exists because the planet is evolving alongside its biosphere. That life and Earth are intertwined in a deep feedback loop spanning eons. As biological complexity increases, environmental pressures change. As environmental pressures change, planetary systems must adapt. Perhaps the reset is a mechanism to avoid collapse, to prevent runaway conditions, to ensure long-term stability by periodically clearing the slate. If so, then the Great Unconformity was not a catastrophe. It was maintenance, a deep time recalibration, a planetary renewal. And now, the most unsettling question emerges. If the cycle is real, and if the crystal archives encode its rhythm, then where are we now? The answer is not exact. Geological dating carries uncertainties. Magnetic patterns shift. Cycles blur at the edges. But most models place humanity near the rising slope of a new transition, not at the threshold, not at the collapse, but at the beginning of a sequence that may unfold over millions of years. We stand near the ignition point of a new geological chapter, a chapter that may reshape climate, continents, oceans, and even life itself. Subtle signs already appear. The magnetic field is weakening faster than expected. Continental drift shows emerging patterns not seen since the distant past. Deep mantle plumes are rising. Ocean circulation is changing. Species across the world display unusual rates of adaptation and stress response. And beneath it all, the planet is accumulating the same types of energy differentials seen in the lead-up to previous resets. Nothing suggests an imminent catastrophe, but everything suggests a shift, a transition that humanity will witness in slow motion. A transformation that does not simply reshape landscapes, but reshapes possibility. Because if the reset prepares the world for new biological potential, then the changes ahead may affect us in ways we cannot yet imagine. This brings us to the most intriguing layer of the cycle protocols. Some patterns embedded in the crystal archives appear linked not to geology, but to biology. They reflect rhythms of metabolism, growth, and organization. It is as if the planet anticipates changes in the biosphere, as if the cycles of Earth and the cycles of life are synchronized. And if the Great Unconformity prepared the planet for complex multicellular life, then the next phase may be preparing the world for something beyond complexity. Something emerging now. A shift not in the crust or oceans, but in consciousness itself. Because in recent centuries, a strange acceleration has taken hold. Humanity is changing faster than the environment around it. Technological leaps. Cognitive shifts, networks connecting billions of minds, the expansion of abstract thought, the deepening of introspection, the global emergence of accelerated awareness. These patterns mirror the pre-reset biological surges recorded in the crystal archives, not in form, but in structure, not in anatomy, but in organization. They resemble the preface to a transition. If planetary cycles shape worlds and biospheres, then perhaps consciousness is the next frontier of transformation. And if so, then humanity may not simply be witnessing the early phases of the next reset. We may be part of it. When we trace the arc of Earth's history from molten beginnings to the complexity of modern life, it is tempting to see evolution as a story driven only by biology, a story of survival, mutation, and adaptation shaped by the slow pressure of environmental change. But as we approach the end of the Great Unconformity narrative, something else begins to emerge. A pattern not written in fossils or rock, but in the living world that stands atop them. A pattern written in us, because if the planetary reset made way for complex life, and if later cycles shaped ecosystems and species in waves, then the next transformation may not be geological at all. It may be unfolding within consciousness. Across the world, something strange is happening. People speak of moments of clarity and insight that come without warning. They describe intuitive leaps, unexplainable awareness, sudden shifts in perception, or the feeling that something inside them is waking up. These experiences were once considered rare, mystical, or isolated, but today they appear with surprising frequency. They cross cultures, languages, and belief systems. Psychologists call them altered states. Neuroscientists call them coherence patterns. Physicists sometimes frame them as resonances between biological systems and the environment. None of these explanations are wrong, but none are complete, because the pattern is global. Individuals separated by oceans report similar sensations at the same periods of time. Their experiences follow repeating cycles, and the timing of these cycles bears a quiet resemblance to the ones embedded in the Crustal archives. It is as if humanity is beginning to reflect the same rhythms that once reshaped the planet. We are accustomed to thinking of consciousness as an emergent property of the brain, the byproduct of neurons firing in elaborate networks, and in a biological sense, that is true. But consciousness is also relational. It interacts with the environment. It responds to external conditions. It evolves with the world around it. When oxygen levels rose after the Great Unconformity, complex life emerged. When continents reorganized during later cycles, ecosystems diversified. And now, in this age of accelerating knowledge, expanding communication, and rapid technological integration, consciousness itself seems to be reorganizing. Multiple studies suggest that the human brain is becoming more efficient generation by generation. Neural scanning reveals that networks once separate are beginning to integrate. Young people show higher levels of cross-hemispheric communication than their ancestors. Collective behavior across populations shows patterns of synchronization once seen only in tightly bonded groups. It is as if a new cognitive architecture is forming. Some scientists argue that this is the natural consequence of cultural complexity. But culture alone cannot explain the speed, nor can technology entirely. Evolution moves slowly, except during transitions, periods when environmental pressures create the conditions for rapid change. But what if the pressure now is not external, but internal? What if the next evolutionary frontier is not physical adaptation, but the expansion of awareness itself? Look at what consciousness has accomplished in a short span. Humanity has mapped the genome, split the atom, observed distant galaxies, and connected billions of minds into a single global network. We stand at the threshold of artificial intelligence, quantum communication, and neural interfaces. For the first time in history, human thought is merging with the tools it creates. This merger accelerates learning, creativity, and memory. It dissolves the boundaries between individual and collective intelligence. And in doing so, it mirrors a pattern familiar from earlier eras of planetary transformation. Separate parts becoming integrated, complexity becoming coherence, systems behaving not as isolated units but as unified wholes. The same transformation that once shaped cells into organisms may now be shaping individuals into something larger. Some philosophers call this the dawn of planetary consciousness. Others see it as a natural next step in the evolution of a thinking species. But from the perspective of deep time, it fits perfectly within the structure of the billion-year cycle. If Earth resets itself to create new physical conditions for life, then perhaps consciousness resets itself to create new realities for experience. The planet reorganized its crust, oceans, and atmosphere. Life reorganized its genomes, body plans, and ecosystems. Now humanity may be reorganizing its mind. And this shift is not only occurring in individuals, it is happening between them. When millions of people share ideas instantly, patterns emerge. Ideas evolve like organisms, combining and replicating at speeds impossible in earlier eras. Thought becomes a collective process. Insight spreads like a wave. Innovation compounds. Belief systems merge or collapse. Humanity begins to function like a single distributed neural network. This does not eliminate individuality. It enhances it. Just as cells remain distinct within a living organism while contributing to its overall function, individuals remain unique while participating in a larger field of awareness. This larger field may be what earlier civilizations referred to in myth and philosophy. The idea of shared mind, collective spirit, universal intelligence. but where they framed it mystically, we can observe it empirically. Brain scans show coherence between groups engaged in shared tasks. Heart rhythms synchronize between individuals in proximity. Attention patterns propagate across populations through social and digital networks. Consciousness, it seems, is not confined to the skull. It extends into relationships, environments, and systems. And if that is true, then the next reset may not be about destroying or rebuilding the planet. It may be about transforming how consciousness interacts with reality. There is another layer to this shift. As humanity expands its awareness outward, exploring the cosmos and building simulations that reflect physical laws, our understanding of reality itself is changing. We see the universe less as a static machine and more as a dynamic, interconnected field. A field where matter, energy, information, and consciousness are intertwined. Quantum experiments demonstrate that observation affects outcome. Cosmology reveals that the majority of the universe is invisible, intangible, and yet fundamentally influential. Physics increasingly describes reality in terms of probability, resonance, and entanglement. These concepts, once philosophical, are becoming scientific, and they suggest that consciousness may not only perceive reality, it may participate in shaping it. This is the core of what some call reality engineering, the idea that as consciousness evolves, it gains the ability to influence the patterns that govern experience, not by violating physical laws, but by interacting with them at deeper levels, by aligning intention, perception, and environment in ways that subtly shift probability and outcome. This is not magic, it is an emerging science. And like all sciences, it begins with observation, continues with pattern recognition, and culminates in mastery. If the Great Unconformity prepared the Earth for complex life, and if subsequent cycles shaped biological and ecological diversity, then perhaps the current cycle is preparing humanity for a transformation beyond biology. A shift in how reality is experienced, interpreted, and co-created. Indicators of this shift appear everywhere, in rising interest in inner exploration, in increasing reports of intuition, synchronicity, and profound insight, in the global spread of practices that cultivate awareness. In scientific studies revealing that intention can influence neural plasticity, immune function, and even group behavior. It is as if consciousness is waking up to its own potential. If earlier cycles shaped the planet and its organisms, then this cycle may be shaping perception itself. For the first time, evolution is no longer confined to the physical realm. It is occurring in the mental and experiential realm. Humanity is learning not only to understand reality, but to participate in its unfolding. And so we return to the core idea of the planetary reset, not as destruction, not as catastrophe, but as transformation, a transition between states, a reorganization of possibility. The missing billion years were not a void, they were a threshold, a moment when the old world ended and the new one began, a moment when Earth rewrote itself. Today, standing at the dawn of the next cycle, we face a similar threshold, not one of geological upheaval, but of conscious evolution. The planet is not ending, it is preparing, and so are we. In deep time, life emerges, evolves, and awakens. Worlds reshape, biospheres recalibrate, and consciousness expands. Every reset is a beginning disguised as an ending, and perhaps the next chapter is not about what Earth becomes, but about what we become. If this journey has sparked something in you, consider liking the video, sharing it with those who would explore these mysteries with us, and subscribing to the channel for more stories hidden in the deep time of our world. Thank you for being part of this path of discovery.